Hi, everybody. Good morning, good afternoon, good evening. Also, very happy Diwali to you all. I'm Neha Kumar. I'm one of the technical program chairs of the CHIWORK series and faculty at Georgia Tech. And here I do research on the intersection of HCI and global development, critically reflecting on the various recrafting of futures in the context of development in various marginal settings. And in this series so far, we've been talking about the future of work from many different perspectives. We've looked at the technology itself and digitally automated futures. And then last week, we talked about tech workers and how they are impacted. And today, we're going to take a slightly broader view to see what futures we're headed towards as a planet and what role we might play as computing researchers, students, and professionals. And I really can't think of anyone better to be having this conversation with. So I'm delighted to welcome today Barath Raghavan to CHIWORK. Barath is an assistant professor at USC, University of Southern California. His research expertise is in the area of computer networking, but that's a side to him that I know very little of. I'm mostly familiar and very much inspired by the work that Barath has been doing in the limits community. And I'm going to ask you, Barath, to just introduce yourself maybe, and maybe talk a little bit about both these sides to your work briefly.
All right, can you see that?
Yeah.
Excellent. And thanks for inviting me and for the introduction. And yeah, so my background's both conventional and unconventional in that I, on paper, am a networking researcher and have been for a long time. And that's what I, got my PhD in, what I've been doing, since my PhD many years ago, but also have had this strong interest in sustainability and thinking about sort of large scale, civilizational scale issues, maybe is the way to put it, and our role as computing researchers to grapple with those larger problems. And so what sort of evolved for me is a combining of these two parallel threads, sort of my personal interests in life on questions of sustainability and broader notions of, what's our role in society, and my computing research. And so I still do some networking research, but I'm combining those two threads as much as I can these days. And so I'm going to sort of have a very, very high level talk about what I see as the big problems that we're thinking about globally and what these limits are and, how we're sort of grappling with or not grappling with them. And then what are some things that we could be thinking about as computing researchers to start addressing those problems. And, there are some nascent efforts to try to address them in various research communities. The HCI community is actually ahead of many other areas of computing in this regard. But we can definitely do more within the HCI world and within computing more broadly, both in research and in industry. So with that, let me just jump into this very high level question of where are we headed as a global society on planet Earth, and what can be done about it, and what should we be doing about it? And I'm happy to sort of drill down into minute level details of questions of energy and climate, which are some of the things I'm going to briefly go through. But really the big question that I'm always thinking about are limits to what the ecosystem can handle in terms of the emissions that we produce. And then also the flip side, which is the sources of energy and of resources that are fundamentally limited on our planet and that we are drawing down at a rapid rate. And so the question always comes to how do we use energy and what are the consequences of how we use energy? And that's really the prime driver for a lot of the problems that we face today. So a long time ago, I had done a calculation of my personal sort of energy footprint, and really there's a lot of elements to it. Flying is one big one. And in academia, I'm glad to see that because of sort of conferences going virtual, we've reduced our flying, for example, and I hope that continues. But then there's all these other elements, right? Food and housing, and the stuff itself has an embodied energy to it, and commuting and so on. So this is just one piece of the personal profile, but then we got to think sort of bigger and think, what's the efficiency gains that we can have globally. But going beyond efficiency, we want to think about sort of how do we structure society. And climate change ends up being a big driver of this, in that once, if we were able to just consume, use resources, use energy with no consequence, then it would be driven largely by the limitations of the energy itself, right? If we, we're running low on oil, running low on other fossil fuels, but we didn't have climate change impacts, then it would just be about substituting one energy source for the other. But climate change really is the biggest driver now for these changes that we need to make. And often people don't talk about, why are we doing these changes? What are the big consequences that we're facing? And so, people talk about these questions of, oh, we're going to have this many degrees C of warming and so on, and we're trying to avoid, some of those effects. But right now we're kind of locked into roughly a 3 degrees C world, unless, some pretty rapid changes are made to policy and to practices and to culture. And supposedly, the sort of broadly agreed upon red line, which we should not cross, is this 2 degree mark. And even for the 2 degree mark, we've had about 1 degree of warming so far. 2 degrees is pretty bad, right? We're talking about probably we don't have any ice in the Arctic for the summer. We have, extreme storms of all kinds. We've had, just like we've already started to see. But once we get to 3 degrees, the consequences we're talking about are, on the scale of billions of people being affected on an annual basis. And we don't really know what the effects are. It starts getting to be very unknown. We're talking about a very different world, and it could be a world that we're living in fairly soon. And so the urgency is really not widely felt, or not widely felt enough, it seems. And given where we're at, it also seems that there isn't very much chance that we're going to stay below 2 degrees C. So we are entering this unknown territory. And so the question is, what do we do about this unknown territory we're entering? We can change our behavior, so we can use less, and we can change our sources of energy, and we can find more. Now, clearly, changing our sources to find more fossil fuels isn't going to be a good idea. So we need to change to something else. And so Tom Murphy has an excellent blog, and now a full book that he's written on different types of energy sources that are available to us. Now, one of the things that's remarkable, and we don't always grapple with, is that all of the alternatives that are out there, to the current fossil fuels that we depend upon, are not quite as good of energy sources as fossil fuels are, if you ignore the climate change aspect, right? So if you look, he sort of does a scoring here. The scores for petroleum, natural gas, and coal are quite good, which means that those are the best sources of energy if you ignore the pollution piece. And so we're stepping down in terms of sort of energy quality. We're having to make compromises. And so helping society grapple with those changes and the consequences of those changes, that's actually a pretty big role for computing. Now, we always thought that we were going to get some magical source of energy that was going to get us out of this, but it never came. And so what we're talking about is moving the world to a totally different profile of energy, and it's got to happen in a very short amount of time. So this is something from Saul Griffith's talk from some years ago. Hasn't really changed. The picture hasn't changed globally. So he just sort of said, okay, well, what if we switch to some portfolio of various energy sources? The consequence, though, is if you actually run the numbers on how much has to be built globally, we're talking about building a remarkable amount of physical infrastructure over something like 20 years. And the world doesn't have the manufacturing capacity to do this right now. And so when you actually put the numbers together, and this is these are rough estimates of what manufacturing potential is for solar and wind and so on. It doesn't at all match up to what would be needed to move the world to renewable energy in the next 20 years. And so effectively, we need a sort of crash program. We rapidly change the global energy infrastructure in 20 years. If we do that crash program, we would be about 50% short of the actual target. And so that's where I sort of step back and think about the classic studies from the limits to growth. And so this is the classic book from Danielle Meadows. Started, the first version was in the 1970s, and then they did a 20-year update, a 30-year update. So this is from the 30-year update from 2004. It's a very rough simulation of various important sort of factors in the world, where they said, okay, well, let's say we just start with a basic world model, it's a sort of economic ecological model. And we look at existing policies, existing industrialism, existing, economic agricultural systems. In their baseline scenario, the industrial system will continue to grow and continue to grow until it starts running low on non-renewable resources, which we're starting to enter that period where the non-renewable resources, especially fossil fuels, but not just fossil fuels, start becoming limited. Once that happens, we enter a period of resource crisis where the industrial system cannot keep growing, but since it's a growth-based system, all of these other important things like food production, industrial output, and so on start to decline. And in a consumer-based economy, that means that sort of overall welfare in a society starts to decline. Now, to get out of this scenario, what a natural thing is to do is to try and find more resources. And so if the society is able to find more resources, then it's able to continue growing and continue growing even further. And so it postpones the crisis, but then enters what they're calling a pollution crisis, where the amount of impact on the ecosystem is so great as a result of that growth and of the use of non-renewable resources that, like we're seeing with climate change, we would then have sort of a climate overshoot. Those are not two particularly pleasant futures that we have to choose from. And so the question is, how do we navigate that future? This is not something that's new. Carter said in 1974, this change will either be made on our own initiative in a planned or rational way, or forced on us with chaos and suffering by the inexorable laws of nature. This has been a sort of known challenge, the way that we use resources and the consequences it has for our life. So where are we headed? And so that's sort of where we're headed. So what can be done now, and what should we be doing as computing researchers and practitioners? Now, the two natural places to go are to think about sustainable computing and computing for sustainability. Sometimes these two terms are conflated as just sustainable computing, but I think it's useful to break them out and think about sustainable computing being making the actual computation sustainable, making data centers use renewable power, making manufacturing enable devices to be reused and recycled and repaired. That's all sort of the work of sustainable computing. And a lot of focus, rightly so, is on that because it's something that we can do as computing researchers, because we control sort of what computing does. And it's also a place where a lot of power is used, right? Data centers use a lot of power, devices use a lot of power. So it's natural to focus on that. Computing for sustainability is using our skills as computing researchers to address sustainability problems that exist globally. And that's a pretty important area for the simple fact that for better or for worse, society has been looking to computer scientists and computing researchers to solve the problems of humanity these days, right? If you look in the last 10 years, whether it's health or education or finance or law or you name it, every sector has been looking to computing to solve its problems. And so we have a unique role right now that the resources and the focus is on us. So we should make the best of it and actually use that focus to help address the problems of sustainability globally. But if you actually sort of put numbers to this, I would say both in terms of the impact and in terms of the, and as a result, the importance should be something like 5% for sustainable computing and 95% for computing for sustainability. And that aligns also with the impact. Like if you were to take what's the carbon emissions of computing, it's 5% or less. Depending on the study, it's going to be somewhere in the 3% range globally, right? So many other sectors have greater climate impact. And so we should be looking at all those other sectors. How do we make them more sustainable? And that's not to say we shouldn't do sustainable computing work. I do some sustainable computing work, but I also do a fair amount of computing for sustainability. So what are some of those big sectors that we should be looking at? We should be thinking, how do we help farmers be more sustainable? How do we make agriculture more sustainable? Is the largest source of emissions globally is from agriculture. And the systems of agriculture today are highly unsustainable, but they don't need to be that way. There are many alternative methods that are more sustainable and still produce high yields, but they're more complex to do. We have to figure out how to make that possible for farmers today. Transportation is, of course, a very large energy consuming sector. What can we do as computing researchers to not just make it more efficient, but actually change the way people transport themselves and goods and make that whole sector more sustainable? Power generation, of course, is, maybe there's not direct means for us to affect how power generation is done, but there's always work in the power generation sector. There's people working on smart grids, there's people working on demand response and all sorts of sort of computing for power generation. And then manufacturing. Manufacturing is very broad category, and computing can be used in all sorts of ways to improve the sustainability of it. But let's step up one level from this. This is sort of very, sector specific. What are some of the things that we, stepping back, might think about? How can we use computing to change the way that we think about consumption? People think about themselves often, use the term, I'm a consumer, right? And the language we use is this notion that we are consumers in a sort of a consumption-driven economy. How do we change that? How do we change the ways people think about consumption, act as consumers, or preferably not as consumers? Also, the flip side, how do we think about the notion of production, both production as in manufacturing, but also the notion that production is actually done by the manufacturer rather than production being the extraction of natural resources from the ground that are part of nature, but then become part of the human economy as a result of that extraction, right? So there's ways of thinking about it differently that then can also be sort of have ripple effects that will eventually have sustainability gains. Finance is a driver of a lot of the growth-based system that we have today. And so as finance drives further and further growth, economic growth, and the pressures for growth due to the way that finance works, we then may see greater cycles of consumption and production and consumption and production. And then finally, governance, of course. We need to have systems of governance that enable sustainable outcomes to be preferred over non-sustainable outcomes. And that's a tricky thing because, it may be that an elected official wants to say, oh yeah, we were able to deliver on X% GDP growth this year. And so the metrics themselves become ingrained and then become a driver. And so how can computing help provide visibility into some of these harder to quantify goals, such as various sustainability goals? And then finally, stepping back even further, things that computing is really embedded in culture now. And so we have the means, it's a weird thing, but we do really have the power to shape culture in computing. And so how do we shape that culture towards a more sustainable culture? How do we help people gain broader perspectives? And through those broader perspectives, include perspectives about how humanity and the earth are interrelated and interdependent. How do we help people gain flexibility in their lives so that they don't become dependent upon the existing systems of production and consumption, see themselves narrowly as consumers in a growth-based economy, but instead gain flexibility of perspective? And as some have talked about in computing research and beyond in ICTD, how do we help people cultivate wisdom about all of these matters and about sustainability? So that's sort of the highest level that we can sort of be thinking about our role in computing, and that has ripple effects down to addressing problems with sustainability and computing within limits. And so finally, I just want to end with a quote from Danielle Meadows at close to the end of Limits to Growth. She says, we shouldn't be thinking of that industry is the cause of all problems or the cure, or government is the cause of all problems or the cure, or environmentalists are the cause of all problems or cure. Any other group is the cause or the cure. But all people and institutions play their role within the large system structure. In a system that is structured for overshoot, all players deliberately or inadvertently contribute to that overshoot. In a system that's structured for sustainability, industries, governments, environmentalists, and most especially economists will play essential roles in contributing to sustainability. And so I see computing as having two roles here. One is in changing that system structure to move to one which is structured for sustainability. And then on all of the different sort of sectors of the economy as it exists and of human life, helping people transition from what they do now to this future that is structured for sustainability. Thanks. That's all I have, and I'm love to chat with you all.
Thank you. Thanks, Barath. Okay, so just very quickly, I had asked Barath to do this talk just so that she could orient us a bit to the things that we'll be talking about after. And I know that generally we don't really do slides, but I think these slides were really helpful. At least I think they will be for starting this conversation today. I want to ask if someone could just quickly post a link to the code of conduct, just so that Navina or Alberta, if you could please help with that. And then for the format today, we'll start with a couple of questions that I will pose to Barath, and then in the meantime, feel free to just share your questions in the chat, and we can get to those. And I think there's questions here that are about HCI, about computing, but also just as individuals, the role that we play in whatever area of work we're participating in, right? And so I think there'll be plenty of time to get to those, I hope. So I guess I want to start, Barath, by asking you to do two things, and you can do them in whichever order you'd like. One is to sort of talk about, and you did refer to these things, but maybe we can just tease those out and then see what they mean to us. So the first one is just like what you said that computing has a role to play, and I'm also trying to understand how computing has a unique role to play. So vis-a-vis other fields, why you think that that computing professionals or students, researchers, practitioners have a particular role to play. And then the second question is bringing it, I guess, much closer to home. So thinking about HCI research, practice, education, and how we can bring these ideas closer to us, such that even for people who aren't necessarily researching these, what are contributions that they can be making or thinking about? And yeah, I think let's start there, and then we can see where the conversation goes.
So I think the reason that I see computing as having a unique role is that computing broadly is the interface now between every person and every sector of the economy. We use it to buy things. Companies use it in every facet of their operations, and so it's the ubiquity of computing in everything that in modern life that is why it's such a key leverage point. But then the other piece of it is that it's that I sometimes think this just as a random an example of how this plays out. If we think about some of the terminology that we end up using that becomes part of everyday speech, a lot of those terms come from some engineer at some company built some app that uses some term, right? Like when we say you're going to swipe on a phone, probably some engineer somewhere at Apple or some company said, well, yeah, that's going to be the sort of the gesture. That's going to call that a swipe. And then everybody uses that term, right? Now that's a word that has become ubiquitous. And I use that a language example for the reason that it shows the power of the sort of the infinite scalability of software and of computing that, within a small number of years, all of a sudden 3 billion people can be using some new app or some new platform just because it can scale like that. And so the influence that computing ends up having is way outsized compared to if a student goes and studies computer science or something, computing adjacent and builds something, they can have an impact on a scale that it's just not possible to do in almost any other field of study today. Whether that's right or wrong, I don't know. I mean, there's a lot of problems that creates, but that's sort of the way it is right now. And so we may be able to take advantage of that fact that, in every sector, people are looking at, if you're doing health, you're trying to do health IT, health, health informatics, health, bioinformatics, right? It's all about how do we use computation, how do we use data, how do we use computing tools to improve X, whatever X is. And so we can be doing that, but then in all of those sectors be focused on sustainability.
Got it. And I guess one of the reasons I was asking that is also in the field of, HCI and development, right? I didn't get into the field, for instance, and many of my colleagues didn't, to think about development first. It was technology first, and then looking at technology's applications. And I think that even with sustainability, it's possible that people come into the field thinking about computing first, and then later become more present to the challenges around sustainability, and so start to think about how to take their knowledge and expertise and apply it in this space. I wonder how many people do it the other way around, so thinking about sustainability challenges or climate challenges and then studying computing as a way to address those challenges. Do you have any thoughts on that?
So I think I did both at the same time, which is a weird thing to do. So I had interest in sustainability for a really long time, since I was a kid, but never saw a way to bridge the gap between computing research and what you're supposed to do as a computer science researcher and those sustainability interests. So those sustainability interests just continued as personal hobbies more than anything. And then on the other side was computing. And so I thought, well, where's the natural stepping stone to sort of get a little bit closer together? And it was sustainable computing rather than computing for sustainability. So I started looking into what's the energy footprint of data centers and of the internet and manufacturing of computational devices and all this stuff. So that was the natural place. And I think a lot of people go through that trajectory. They say, well, okay, I'm a computing person. Computing is not very sustainable because of all the energy it uses. Let me try and make that better. Sometimes that's the place where they stop. But what I would like to see happen is people go way beyond that and say, okay, computing is a problem, but there's so much more that we can do with it to fix broader challenges, and then go into computing for sustainability.
Okay, so coming back to my second question, I guess, which was about HCI. So thinking about particular methods or techniques or approaches in HCI that might be of use when we think about either sustainable computing or computing for sustainability.
So this is where I'm way out of my depth, because I don't think of myself as a particularly knowledgeable about HCI generally. So even though I dabble in the HCI community, I don't feel like I know. I guess, there's, from an outsider's point of view, and so forgive me for oversimplifying what is a very large field, I see sort of two broad camps in that I see the analytical HCI work, which is about sort of critical analysis and theorizing and so on. And then the more sort of, we built this cool user interface, or we built this cool thing, this cool hack, and we studied it and people thought it was neat. And those are sort of two very different camps of the HCI community. And I wonder if there's room for sort of something in between the two that is focused on sustainability, which takes the perspectives that are learned from the sort of critical wing and then puts them into practice using the tools of the, you know, we built this cool thing wing, for lack of better, I don't know what you would call those folks. And, you know, there's a attraction that the sort of broader public has to, you know, shiny gadgets. And we see that every year, right? People are buying shiny gadgets all the time. Maybe we can leverage that and leverage the ability of the HCI community to produce novel user interfaces, novel user interaction with computing, but towards ends that are informed by the critical analysis, informed by sustainability literature, to change culture. Because I think that's the big leverage point here. We can change culture broadly, not just within computing. The way people think of how computing then leads them to not be consumers, but be, you know, animals on this planet instead, right? There's a different way of we can shift the mindsets of people, which then has these ripple effects for sustainability.
Mm-hmm. Yeah, I mean, changing culture is not an easy thing to do by any means, but absolutely, that does make sense. I'm going to bring up one aspect of changing culture. So this happened to be on Twitter this morning, and I'm tempted to just, you know, present this idea to you, and I want to know what you think. So this is a tweet about put everything in the metaverse. That's Nick Bidwell. Okay, hang on. I've just shared this.
So I have Twitter blocked on my own computer, so I can't open it.
Oh, that is brilliant. Okay, so this is a question that someone raised, saying, was interviewed about transition design, was asked, but how will you convince businesses who are and have to be focused on growth? Never know what to say. This is a real doomerism, the fatalism of a pseudo-analysis that passes itself off as common sense. And then followed by, I of course said guillotines, which did not go down well. I said degrowth. I said development is unfolding, maturing, and differentiating, not expansion. I said a version of post-capitalism, that most households do not pursue growth, constantly increasing possessions, and so real estate to house them, but stability, that everyday lived values are different from business value measures, and that former is more prevalent than latter. Anyway, so I won't go down further, but basically this, you know, attention around businesses and growth and degrowth, and talking about development as not expansion, but unfolding, maturing, differentiating.
Yes, so I think that description actually really matches the original steady state economics vision from the 1970s. So I actually don't like using the term degrowth, because the word growth has sort of taken on meanings further beyond what it originally meant. And so degrowth then seems like if growth equals good, then degrowth equals bad. And, you know, the conversation ends at that point. So I very rarely talk about degrowth, or I talk about growth and the problems with it, but I don't talk about degrowth as the sort of solution to it. Instead, I'd like to think about steady state economics, and the household analogy is a perfect one. And so in the original daily steady state economics text, he talks about how if you think about any subsystem of a finite system, so the human economy is a subset of human society, which is a subset of the global ecosystem. And if you think about it that way, the global ecosystem isn't growing. So that means that anything within it has to eventually stop growing. So we know that growth will end at some point. Now, the question is when it will end and how it will end. And it seems like we are in the period of time right now, a couple of decades, where growth will end, whether we want it to or not. It will end due to, like the limits to growth study, due to non-renewable resource limits, and it will end because climate change causes major impacts that stop it. So on both sides. And so then the question is, what is the future? Do we try and target degrowth? And I like the steady state model where it is, we have development, we have constant change, but the overall consumption and the overall pollution aren't growing. Those are within the ecosystem's limits. And so, you know, the model that Daly outlines is one of many, but the way that you could think of it is that human society and sort of at all the regional levels, you say, this is what the ecosystem can handle in terms of the amount of pollution in this watershed, the amount of emissions of greenhouse gases, and so on. And this is the amount of water that we can take from the aquifers, and this is the amount of resources we can take out of the ground, and this is the amount of trees that we can cut down for lumber, and so on. All of those things are going to be capped based upon what the ecosystem's renewable resource limits are. And then within that, you can have a dynamic society. Things can constantly change, and new services and new goods and new ideas and all that can flourish, and old ones can go away, and you can have constant change. So you wouldn't have a static society. And that's one thing that I think we have to sort of demonstrate, that a non-growing society can be as dynamic and interesting as a growing one.
Which is also, I mean, it is imposing a certain meaning to the word growth, right? And not looking at it as is pointed out in the tweet. Let's take this question from Andrew. Now, Andrew, would you like to just pose the question?
Sure. Thanks, Barath. Really interesting. So I'm curious what you think about collaborating between computing researchers and others, because it seems like this is very complex. And, you know, I think you mentioned the engineer who says, let's swipe, and then swipe becomes a thing, but we don't want to do that with the environment, right? Because there are some significant consequences that we need to deal with. So what do you think? Who needs to be involved, and how do we proceed?
Yeah, so I have a slightly unconventional way. So I can say how I do it after I say sort of the general. So the general question is, I think, you know, let's say we want to address some challenge of energy or agriculture or manufacturing or, you know, any other sector. Do we go and find experts who are aligned with sort of the direction we want to go in those, and then collaborate with them? And I think that's a good model to go with in general. So we have to have more interdisciplinary collaboration. The challenge becomes, I've seen researchers in computing for sustainability and also in ICTD do this, where there's this sharp divide between the computing folks and the non-computing folks. And then it's just, give us your data, we will crunch some numbers, we'll feed it into our ML model, and then we'll give you some answers. And so then there isn't deeper engagement that can lead to totally new ways of thinking. It's just optimizing what exists already. And so my preference is usually to myself go and deeply immerse myself in the whatever topic I'm working on, so that while on paper I'm not an expert, I feel like I have enough expertise in it. So I've done this with agriculture. And then that leads to being able to sort of think of totally new ways that even the agriculture folks aren't thinking about and the computing folks aren't thinking about. And so we come up with just totally new research programs. And so that's what I'm doing in agriculture. It takes a lot longer to do it that way. But I think it's more fulfilling, in addition to maybe being more productive. I don't know if that gets at your question. I hope it does.
Yeah, it does resonate with that idea of course, I can't remember the author now. The book Range, about specialists versus generalists. I'll find the link, but the argument, the argument in short is generalists have a better chance of succeeding than specialists. So I think you're not necessarily describing yourself as a generalist, but having multiple experiences and then bringing them together is different than having focusing in on one thing.
Mm-hmm.
And this is something that I think comes up, much more commonly as well, Barath, I think. So certainly in my classes, and I teach classes that are cross-listed because I'm jointly appointed, and both interactive computing and international affairs. And I have students ask, how do you work across both spaces, and what is the right answer? Is it through collaborations? And I feel like that's the diplomatic answer to give, to build more partnerships, to have more collaborations, but it's really, really hard in practice to do that. And it really needs people to respect different methodologies, different approaches to research. Just the question around quant and qual work came up today, where people, it can be so hard to see eye to eye on just those methods. And so I think, coming back to what you're saying about being an expert in both of these fields, I guess, how do you bring that to students in our classes, I guess?
So I guess the answer would be different for grad versus undergrad. And so the thing that I've found tricky so far, and I have not figured out how to do this yet, is for graduate work, there's all the incentives point towards narrow disciplinary, least publishable units. And breaking out of that seems really difficult because you need your students to be able to get papers. And so they may want to, or they may be feeling pushed into by the community into doing that very narrowly, there's a well-established area with well-established kinds of questions, problems, methods. I'm going to crank out a paper on that and get some publications. And the institutions that we're in, the funding agencies, they all point in that same direction. And so breaking out of that for students is really difficult. So I haven't figured out a good way of doing that. I mean, I have some students who are happy to go, into the unknown with me on some of these projects, but it may not be narrowly good for their careers in the usual sense of getting lots of papers to then go get an academic position. For undergrads, it's easier in the sense that they're not sort of bought into the academic system, the research system. And so there it's, through education, through teaching, I've mostly been doing, it's not through research. I've been, teaching this class, Computing for Social Good. And as a result of that course, sort of introduce students to, mostly seniors, to the idea of, the role that computing can play outside of the narrow technical stuff that they have been learning during their undergrad degrees. So that's kind of how I've been approaching it. I think it's a work in progress for sure.
Thank you. Navina, would you like to? Yeah.
Thanks, Barath. I really enjoyed that talk and the question so far. So you were talking about the difference between sustainable computing and computing for sustainability. And I'm kind of wondering, so what is the role for computing for sustainability, even when you're not looking directly at sustainability, if that makes sense? Like a lot of us look at work and it might be outside of the sectors that you mentioned, like agriculture or transport, and that's like our primary focus. So in what ways do you think we could integrate with efforts that you're talking about? Or is it kind of, how do you think about it? Is it like all or nothing, or is there ways that people can overlap? Or
Oh yeah, I think there's infinite shades of gray here and ways to overlap. And one way that I like to think about the context of work and sustainability and computing for sustainability is to think about, maybe this is a little bit of a futurism sort of exercise, but it seems to me that computing is going to be integrated with the way we work and is going to shape the way we work and is going to be used in all forms of work or many forms of work in the future. What does a sustainable future, what does a steady state, like if we were to imagine if we were able to make the changes that we would like to make for a sustainable society and we look 20 years from now, what does work look like in that world? Some ways it's going to be similar, but there's going to be tons and tons of differences. And we can think about building computing and work-related tools and practices and methodologies and all of this for that future world that is on the sort of sustainable fork of our current trajectory. And so that's how sustainability can inform that research, even if the goal isn't specifically about sustainability.
Thank you.
So Nick had a comment saying sounds like a commons model, which I think was 2 questions ago. And then Nabil shared a link to the book by David Epstein, the Range Why Generalists Triumph in a Specialized World. Okay, thanks Nick for joining. So I had wanted to get to 2 more things, and I don't know if we have enough time. We have about 15 minutes max. Maybe we should close the recording. Andrew, what do you think? And then we can continue for a few minutes. Okay, so before we close, just thank you, Barath, for joining us. Next week we have Nupur Raval, who will be talking about the future of work in the labor world, and specifically looking at the Global South. And that's a joint audience with the Georgia Tech GBU Center. And with that, let's close the recording.